Hi everyone, we are continuing with improper integrals, except this time I don't have an infinity in my bounds. Hey, what I do have though is something that makes my function go crazy, right, or have an asymptote. So if I plug 0 into 1 over x to the 1/3 power, obviously I'm dividing by 0 and that's no-no. Okay, that's bad. So the way that I'm going to rewrite this is by using a limit. So I'm going to take the limit as a approaches 0 from a to 1, because 0 is my problem number. 1/3 dx. Okay, now if you wanted to rewrite this as x to the negative 1/3, that'd be totally fine too. Right, now we can evaluate our limit. We get 3/2 x to the 2/3 from a to 1. Limit as a approaches 0 of 3/2 times 1, so just 3/2, but you know, I'll write it out because I'm so nice. Okay, so now when we evaluate our limit and plug 0 in for a, this whole term goes away. I'm just left with 3/2 times 1, or just 3/2. Okay, let's try another one. So again, if I plug 0 in to my function, I have an asymptote, and so 0 is a bad number. So I'm going to rewrite this using a limit. Okay, now I'm going to evaluate just like I did in the previous problem. That should be an a to 1. Okay, and I do the first fundamental theorem. So negative 1/2 times 1, so that's just is. And then plus a to the negative second over 2. And then when I plug 0 in for a, bad things happen, because remember, a has a negative exponent, which means it's in the denominator. Okay, I end up dividing by 0, which is equivalent to adding infinity, right? So negative 1/2 plus infinity is still infinity, which means that this is divergent. Okay, it never converges down to a value. It goes on forever. It's really, really big. Okay, and it keeps getting bigger. So there's no area contained in this graph right here. All right, let's try some more complicated functions. Okay, so if I plug 27 into this function, I divide by 0. It's a bad number. So I combat that by rewriting it as a limit. Okay, or if you want to write it as 27 minus x to the negative 1/3, that's also fine. Okay, so I'll evaluate my limit. And if you're uncomfortable doing this in your head, then you can use the U sub and go for it from there. But you should get this. Okay, and when I do the first fundamental theorem, again, I can take this constant out to the front, so I'm going to do that. When I do the first fundamental theorem, I end up with kind of complicatedness, but that's fine. Okay, so looks kind of long, but it's totally fine. Okay, so now when I evaluate my limit and I plug 27 in, I see that this term goes to 0. Okay, here I just have 27 to the 2/3 power, which is 9. So I have negative 3/2 times negative 9. Okay, this negative didn't go anywhere. 27 minus 0 is 27. To the 2/3 power is just 9. All right, I multiply these out, I get 27/2. All right, let's try another one. So here, I actually have a problem spot at 1. If I plug 1 into this function, I end up dividing by 0. I have an asymptote there. So what I have to do is actually split my integral at 1. So remember, if you have an integral and you can split it at some middle point, that's totally fine. Okay, so now I'm going to rewrite this using limits. So I have the limit as b approaches 1. We're going from the left here. The integral 0 to b of x minus 1 to the negative 2/3 dx. Okay, so that's my first integral. Then my second integral is the limit. I'll write as a approaches 1 from the right, but again, you can use the same letter, it doesn't really matter. Of again, x minus 1 to the negative 2/3 power dx. Okay, so now I rewrote it using limits. Now I evaluate my integral. Right, so I get 3x minus 1 to the 1/3 power from 0 to b. Okay, that's my first integral, plus limit a approaches 1 from the right of 3 times x minus 1 to the 1/3 power from a to 3. Oh. Okay. Now again, I do the first fundamental theorem, and I can bring this 3 out to the front, so I'm going to do that. Okay, so that's my first one. Again, I'll bring my 3 out. And I'm just plugging in. So 3 minus 1 to the 1/3 minus a minus 1 to the 1/3. Okay, and the nice thing is I see that when I plug in 1, this term goes to 0. So I just end up with 3 times negative 1 to the 1/3. Okay, and then here again, I have this 3 in front, and when I plug in 1 in for a, this term goes to 0, so I just have 3 minus 1 to the 1/3, or 2 to the 1/3 power. Right, and this looks kind of long and complicated, but this is actually the answer. Okay, so that's my answer kind of in neat simplified form. And one more. And it's not too bad. We just want to find area. Okay, so we want to find the area in the fourth quadrant of 2 natural log of x. And if you know what natural log looks like, it does this situation. So I just want to know what's happening in the first quadrant. So my bounds are going to go from 0 to 1, because that's where I cross the x-axis. And remember, it's top minus bottom. So my top is 0, my bottom is 2 natural log of x. Right? So like this, top, bottom, with respect to x. Okay, now I know when I plug 0 into natural log, it doesn't exist there. Okay, I cannot take the natural log of 0. So I'll rewrite this using a limit. Okay. And then I evaluate my integral. Alright, so this is the integral of natural log of x. And then I do the first fundamental theorem. So I have negative 2 natural log of 1 minus 1 plus, because there's a negative there, 2a natural log of a minus 1. Okay, now when I plug in 0, I am plugging 0 into the natural log here, which shouldn't exist, but I'm also multiplying it by 0, because I have an a here. And if you multiply anything by 0, it doesn't matter what it is, it's 0. Okay, so this whole term is going to go to 0. I'm left with negative 2 times the natural log of 1 minus 1. Okay, well, the natural log of 1 is 0, so I just have negative 2 times negative 1, which is 2. All right, that's it for this. See y'all later.